In this lesson, we shall focus on Euclidean geometry for grades 11 and 12. This topic is very interesting, and let's get started. In the diagram, PQ is the common chord of the two circles. Right, we have P sitting here, and Q is there. Right, is the common chord of the two circles. The center M of the larger circle lies on the circumference of the smaller circle. Right, there it is. M lies on the circumference of the smaller circle there. Okay, what more do we have? Right, PMNQ is a cyclic quadrilateral. We have P, M, and Q is a cyclic quadrilateral. What is a cyclic quadrilateral? A cyclic quadrilateral is a geometrical formation with four vertices, all of which lie on the circumference of a circle. Okay, QN is produced to R. Right, here is Q. And here is N, but it has actually been produced to R, a point on the larger circle. R lies on the larger circle. And M produced meets the chord PR at S. The point S is clear. The angle P2 is X. There it is. It is X. It is X. Give a reason why the angle N2 is X. The examiner is saying the angle N2 sitting here is X. They are telling you that it is X, but give a reason why. Remember, today is the discussion on Euclidean geometry. What do you think is the reason? You have 2 minutes. You have 2 minutes exactly. Let me know when you're done with it. Let me know when you're done with it. Why is the angle N2 equal to X? If what we know is that the angle
Is it not
P2,
exterior angles of a cyclic quad?
good, it is exterior angle of a cyclic quad. There it is. It is exterior angle of a cyclic quad because in grade 11, we were taught that if you have a quad like this, the exterior angle is equal to the interior opposite. If this is X, and that is also X. Exterior angle of a cyclic quad. Exterior angle. So now, give a reason. The reason is that we say exterior. Exterior angle of cyclic quad. You're right. Exterior angle of cyclic quad. Okay, remember we're practicing. These are past papers. These are past papers. We've put together good geometry activities for us to discuss today. All right, let us look at 10.2.2. Write down another angle equal in size to X. Give a reason. The examiner is saying, please, we have another angle that is equal to X. This N2 is X, but P2 is also X, given. But the examiner is saying, please, students, there is another angle that is equal to X, but which one is it? You have 2 minutes. Then we discuss. You have 2 minutes. Then we discuss. Right. We have 2 minutes. Then we
So
discuss.
can you say
Remember, we're
angle
discussing, yeah?
S2? Angle S2.
Angle S2. Okay, that's fine. That's fine. I mean, I go with any statement you give. If you want to give a statement about S2 to say angle S2 is equal to another angle, it's okay. But what do you think? What do you think is another angle equal to S2? You think it is X, but why would the reason, what would the reason be for this?
So given that PQM is angles in a semicircle, and P angle angle R originates from P and Q, therefore it's like a tan.
Yes,
So
that's
since it
fine.
originates
Yes.
from
I hear
P
you.
and
I
Q,
hear you. That's fine. Because obviously, I mean, you're on point because M is the center of
yes,
the
sir.
largest circle. So if M is the center of the largest circle, here is the largest circle. It means that PM is equal to MQ, and these are radii, right? PM equals MQ, and these are radii, and therefore it is clear that the angle Q1 equals the angle P2 equals X. And this is the fact that we say angles opposite equal sides. Angles opposite equal sides. And this is the reason. And this is it. So the other angle the examiner wants is the angle Q1, which also equals X there. And the reason is therefore that this triangle is isosceles. You can also say these are base angles of the isosceles triangle. Any question on this so far?
No, sir.
No question, move forward. Determine the size of R in terms of X. We've seen that this one is X.
Yeah,
That is also X. What would the size of R be in terms of X, and what is the reason? Too easy.
from I'm saying X equals to 45.
Okay, you can think that X is 45. Okay, but now if you look at this triangle, so you can look at triangle, for instance, in triangle. So to find this one, you say in triangle. Right, in triangle PMQ. PMQ. So we have the angle M1 plus X. Angle M1 plus X is 180 degrees. And what is the reason for this? Angles of triangle. So that then in the end, we have the angle M1, which is 180 degrees minus twice X. So this angle here is going to be, because if you add all the angles of the triangle, the sum is 180 degrees. So that now we have 180 degrees minus 2x. So that now then we have the angle M1, which is the angle at center, is equal to 2 times the angle R. And this is what we did also in grade 11. So the angle M1 is 2 times angle R. Why is this the case? Angle at center.
Yes, two
Right.
times under
And
the
this is
circumference.
angle at center. Yes. Angle at center equals 2 times angle at circumference. And this is it. Right. Angle at circumference. This is it. Which means the angle M1 is 180 degrees minus twice X equals 2 times angle R. 2 times angle R. Dividing by 2 means the angle R is equal to, you divide 180 by 2, you get 90 degrees minus X. 90 degrees minus X. What is the size of the angle R in terms of X? The angle R, therefore, is 90 degrees minus X. Any question and anything you do not understand here about the circle theorem question?
So,
Yes.
would I be wrong if I just said M is 90 due to the fact that it's um what is it? Angled in
Angle in
semicircle.
semicircle. Okay.
Yes, sir.
Yeah, okay. If you were to say angle M1 is 90 degrees because an angle in semicircle, I mean that would be very interesting because that would be true if it's obtained by diameter. So you'd have to
Okay.
identify a diameter.
Yes, sir.
I get your point. You'd have to find a diameter. Obviously, we know that a diameter subtends an angle of what? Of 90 degrees at the circumference of a circle. Okay, we move on.
Wait. Please hold on, sir.
Okay, that's fine. Right. So that's okay. That's very much okay.
Okay, we can move on, sir.
Okay, good. Now the next
Thank you.
question is this one. Good. The next question is this one. Okay, remember this discussion we're having is an exam prep discussion. So we are preparing for the exam, and we are trying to make sure that we cultivate your ability to do the questions, but we practice along. We don't just talk, and then everything is obvious. You can see, okay, this guy is just telling me all the answers, and then in the exam I need to start thinking. So now the thinking must start now. And we must train you now. Okay. Prove that PS is SR. 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 Okay, I'm giving you 2 minutes. Then we discuss the thing together. 2 minutes. How far?
I'm not sure. We're
Okay, that's
still
fine.
trying.
That's fine. Never mind. Good. Okay, I'm going to give you the corrections. Right, one way to do that is to say, if they say prove that PS is SR, realize that you have a circle with a center, and you go back to grade 11. Right, and in grade 11, you are taught that line from center that is perpendicular to chord bisects the chord. Because now you must prove that it bisects the chord. Then the way to prove it bisects the chord, you must prove that it is perpendicular to the chord because the line from center to a chord. Okay, now with these then, we're able to proceed as follows. So we tell the examiner, that means the examiner, in triangle NSR. So you must just prove that one of these angles or both angles are 90 degrees each. Right, so you're going to then say the angle R equals exactly what? 90 degrees minus X. That's proven there. But also the angle N2 is X. We proved this. This was proved. This was proved above. It was proved above. So you have X at 90 degrees minus X. We move forward to the next question. What then do? We find the angle S2. Right, the angle S2. Right, this angle S2. So you can add S2 with this. So if you want, you can just come and do this. Right, you can just come and do this. And say the angle S2, you add also and 2, you also add angle R. 180 degrees. Right, so this is the angles in a triangle. The angles in a triangle. The angle S2 is what we want. The angle N2 is X. The angle R is 90 degrees minus X, giving 180 degrees, which means that the angle S2 is 100 yards. So this one you can just always check. X minus X is actually exactly 0. And this gives us 180 degrees minus 90 degrees gives us exactly 90 degrees, like so. Meaning the angle S2 is 90 degrees, but this is a straight line. Also, S1 will therefore be 90 degrees. By Euclidean theorem, the line segment joining the center of a circle and that is perpendicular to the chord bisects the chord. And at the point that we find that S2 is equal to R, therefore, PS equals SR. Line from center. Line from center, perpendicular to chord. Line from center, perpendicular to chord. Line from center perpendicular to chord bisects the chord. This is it. Line from center. M is the center, and therefore the line from center perpendicular to chord bisects the chord. This theorem is from grade 11. It is used in metric as well. So we have proven by these that PS is equal to SR. Any question, anything you'd like to understand or ask here?
So, I kind of almost reversed it just a bit.
Okay.
I first said angle S1 plus angle S2 equals to 180.
Yes.
From there, I added angle S2 plus angle N2 plus angle R. And then that's where I
Yes,
stopped.
yes, that is what I thought was easier. The angle S1 is this plus this from grade 10. The
Yes,
exterior
sir.
angle of a such a chord is the sum of the interior opposite. The exterior angle, S1 is an exterior angle of this triangle. So the exterior angle of a triangle is equal to the sum of the interior opposite angles, meaning the angle S1 is actually the same as the sum of the angle R plus N2.
Yes, sir.
And therefore, the angle S1 would be, the angle R would be 90 degrees minus X, the angle
Plus
N2 is plus X, isn't it? So that the angle
Yes, sir.
S1 is actually exactly 90 degrees. And we're done with that if we find that S1 is 90 degrees, because we know that line from center perpendicular to chord bisects the chord. And this is it. And that's the answer. Any question?
No, sir.
No question. We move on to more geometry questions. We are celebrating geometry today. Here is another past exam question. O is the center of the bigger circle. O is here. It is the center of the bigger circle. O lies in the circumference of the smaller circle. Here is the smaller circle with the point O on its circumference. OWVU are points on the circumference of the smaller circle. Right, so OWVU are points on the circumference of the smaller circle. TSVU are points on the circumference of the bigger circle. Right, name 4 other angles, each equal to X with reasons. We are tackling 10.1. You have exactly 4 minutes for this one because there are 4 angles, 1 minute per angle. Okay, remember we are practicing here and I'm trying to see if I can cultivate your skill to solve problems during our discussions, but I can make sure that you become more enthusiastic, but also I must give you a chance to practice, because if you are training a soccer player as a coach, It doesn't work to run the whole 90 minutes in the field. So if you get on the pitch and you run the whole 90 minutes on the field of play, and you think that the players will just be able to play by osmosis, it can't work. No matter how much you can wish. Maybe if the coach is God himself, because God can just talk and things happen, you know. But with the humans, you need to take the players, throw them on the pitch, and tell the player, run to the east, to the west, until they're able, you know. And if they run, they fall down, you tell them, my friend, you must run like this, because if you run this way, you'll fall. So this is the kind of coaching we're talking about. Okay, so I know that you guys have been at school the whole year. I know that the exams are coming in a few days. Few days. We're not talking about months, days. That's what we're talking about here. Okay, now let us tackle this question here. Name 4 other angles each equal to x.
Hold on, sir, please.
Okay, that's fine. We're practicing. I want to see how smart you can be when it comes to geometry analysis. Okay, we're going to go higher and look at even more tougher geometry. Right, we are practicing. Okay, what can we see? We can see that O1 is 2x. O1 is 2x, and this 2x is an angle at center. It is shown an angle at center. We are looking for 4 other angles, each equal to x with reasons. This is it. This is it. So now you are at liberty to indulge.
Oh, okay, I see something.
Okay, I'm happy that you're able to see something. That's what we want. We are practicing, and we know that this is easy, but we must practice and play with it. Past exam papers. This is what we're dealing with today. Geometry, Euclidean geometry. Euclidean geometry. Euclidean geometry. Right. We are back to grade 11. This is what these theorems are. That is where the theorems are coming from.
Like
Euclidean
the
geometry.
cyclic quad, we have angle S1.
Angle S1. There it is. This is it. Angle S1, because we know from grade 11 that if we have this kind of a shape, right, ST, right, we have STU. So now this angle, it's 2x. We know that the angle at center is 2 times that one. So if the angle at center is 2 times that one, this must be x. So that this angle is 2 times this, and therefore the angle S1 is actually exactly x. It is x degrees. Why is it x degrees? Angle at center. Angle at center equals 2 times angle at circumference. And this is it. Angle at circumference. Right, angle at circumference. Good, there we are. We're interested right now in dealing with more of these geometry questions, and we'll tackle the next question.
Angle V3 equals to S1.
Good, the angle V3. Excellent stuff. The angle V3 equals S1. Why is that the case? So the angle
That's cyclic
V3,
quad.
is S1, which is already equal to X. Angles in the same segment. Angles in the same segment. This is it. Angles in same angles in same segment. Angles in same segment. And then now, next we're going to do angle what? I don't want to tell you. Okay, because now if I tell you, then you have nothing to learn. I can only tell you next. But I must first give you a chance to try something. There's another angle that is equal to x. Which one is it?
Hold
There is
on.
another angle that is equal to x. Which one is it?
Oh,
Yeah.
but it doesn't have a I'm not too sure.
Okay, because remember we're practicing. Anyway,
Oh,
I can just give you one more. I can give you one more.
oh,
This is like a game. Okay, because now this O is the center. O is the center of the bigger circle. So here is the bigger circle, and therefore this one here, the line from the center, the circumference is called the radius. And therefore this here and this here would give us exactly x, meaning the angle U. The angle U. The angle U equals xy. Right. The angle U equals x, y, if that's the case. I said the reason for that would be that at this pointer, you are able to see that O is the center of the bigger circle, meaning we have a radius and a radius, and therefore we are able to make an observation there. So the angle U is also V3, which is equal to X. You can write that. So the angle U equals V3, which equals X. So the angle U is V3, which equals X. Why is this the case? Right. The reason for this is that OV is
it's
equal to OU radii. But most importantly, in particular, that is what. So now you then continue to then say um, base
so
angles of, yes, please.
so can you see the one without a letter like that's in between O and V?
Let's check it. Let's check it out. Okay, between O and V, this one here,
Yes, the one bottom left.
bottom left. Okay, so now we're going to look at this and we look at bottom left. Is it this one here?
No, 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 no. By the circle, exactly where you put the circle.
By
Oh,
your, okay, like here.
yes,
Okay, you think that it is
oh,
also
no, 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 bottom one. Never mind, never
bottom
mind, never
bottom? You
mind.
mean this one?
Yeah, but I see, never mind.
Okay,
I
that's
thought it was just
fine. Yeah,
between.
I mean that would be very interesting. But the examiner did not want that one because they should have given it a name. You know?
Okay,
Yeah,
yes,
but I mean you can be right that you can see that one as well. But it's just that normally if they've not given it a name, uh,
yes,
normally it would just be extra. To just be extra. But yeah, okay, right. So we're saying OV is OU radii, and this you then say angles opposite equal sides. Angles opposite equal sides are equal to each other. This gives us angle U equals V3. Next, there's another angle we want. We need more angles, please. What other angles are there? Okay, just teasing you. You have just one more angle to find because they're like we needed four, so we have one, two, three. Okay,
are
don't.
you allowed to construct, sir?
Okay, that's a good point. You're allowed to construct, often not. Unless otherwise, but in these kinds of questions, we don't normally construct because there's normally like more information already. Um, but it's easy. It's easy.
Oh, W1.
W1, there it is. This is it. W1. Right, W1 is actually exactly equal to the angle V3 equals X. Why would W1 be V3, which is equal to X? Why?
Angles in the same
Angles
segment.
in same segment. This is it. Angles in same segment. Angles in same segment. This is it. Angles in same segment. This is it. So now we have this and we continue to do the next thing. Right, we continue to do the next thing and yeah. So next, you need to now determine the size of W2 in terms of X with reasons. W2 in terms of X with reasons. This is it. What do you think of that one? We have 2 minutes. So we need W2 in terms of X with reasons. Where is W2? This is it. This one here. We want it in terms of X with reasons. What do we say? You have 2 minutes. You have 2 minutes. You have 2 minutes. But you've already found like this one, we found it to be X. V3, we found it to be X. S1, we found it to be X. You know. And so now we just need W2 in terms of X. Too easy. And W1, we actually were able to see that as well in terms of X. W1 was found to be X as well. We're asking the question, what is, determine the size of W2 in terms of X with reasons. W2, there it is, in terms of X with reasons. What is it? What is it? What is it?
So can't it be 2x as well?
Okay, that's fine. Remember, we're practicing. I'm testing you every time I ask you a question because I want to know how well you can be able to deal with
Oh
geometry.
no 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 no. I'm not sure, sir.
Okay, that's easy because first and foremost, W2 is O2. W2 equals O2. And why would W2 be equal to O2? These are angles in same segment. Angles in same segment. This is it. Angles in same segment. Right. But the angle O2 is a good angle because this is a straight line, straight line. So you can then say 180 degrees minus 2x. So the angle O2 is 180 degrees minus 2x. And these are what? These are angles on a straight line. Angles on a straight, right, on a straight line, like so. And therefore, the angle W2 is O2, but O2 is 180 degrees minus double x, and that is the answer. And this is 180 degrees minus 2x, but also this one is 180 degrees minus 2x. So they want W2 in terms of x with reasons. W2 is 180 degrees minus 2x. Any question on the geometry?
Thank you, sir.
Too easy. All right, we move on to the next one. Prove that WS is WV. Prove that WS is WV. We have 3 marks. You have rather 3 minutes, excuse me. Too easy. You have 3 minutes. 3 minutes. Want to do 10.3. But you already know this is X. V3 is also X. S1 is X. And we have knowledge of many more. W1 is X. Prove that WS is WV. Prove that WS is WV. Right. Okay. Prove that WS is WV.
So can you do it like in triangle form?
Yes, you can. Doesn't matter. It doesn't matter. It doesn't matter. So just a little test. It's just a little test. Just a little test. Just some little test. Think about it. Right. Right. How far?
Not
Want you to prove that WS is WV. WS is WV. We have 2 more minutes. 2 more minutes. Two more minutes. Right, there it is. Two more minutes. How far? This is it.
wait, so just 2 more minutes. Sorry, sorry.
All right, then we shall give you the corrections. Yeah, in the next 2 minutes, we shall give you corrections because it's too easy, but we're practicing. We have thousands of questions on geometry to train your geometry skills. Thousands. Right. We have thousands of questions. How far, Lissetti? Okay, let's give you the corrections because I think you're thinking too hard. Okay. Okay, remember that O is the center of the circle. O is the center of the larger circle, so that now it subtends this angle here. And this,
Yeah, I already got that part. I got that part.
oh, you got that part. Very well done. So that now you have the angle S1 plus 2. Thank you so much, Delisadi, which is exactly 90 degrees. This is an angle in semicircle. We're just testing you, remember. It's an angle in semicircle, so the overall angle is actually exactly equal to 90 degrees. It is 90 degrees.
Yeah, I think I
Right,
got
so
it.
good. Now, this means the angle S2 is 90 degrees minus x. Therefore, the angle S2 is 90 degrees minus x, which means the angle V1, therefore, can be seen as W2 minus the angle S2, exterior angle of triangle. Exterior angle of triangle. And this is it. Right, so we have here that this is an exterior angle of triangle. Exterior angle of a triangle. So that then in the end, what is the angle W2? We have already said that the angle W2 is 180 degrees minus twice x. We just said that a couple of minutes ago, and we are still adamant it is the case. Right, 180 degrees minus twice x. This is 180 degrees minus double x. The angle S2 is 90 degrees minus x. There it is. And we put it here. 90 degrees minus x. 180 degrees minus 90 is exactly 90 degrees, like so. 90 degrees. But with minus 2x plus x giving us actually exactly a minus x. So V1 is also 90 degrees minus x. S2 is 90 degrees minus x. V1 is 90 degrees minus x. And this triangle here is called isosceles. And therefore, we're able to then say the line segment WS, the line segment WS is exactly equal to WV, and these are sides opposite equal angles. Sides opposite equal angles. Sides opposite equal angles. Sides opposite equal angles. Any question, Lesedi?
No, sir.
No question, too easy. Okay, we continue to practice even much more with the geometry. Let's just get something easy. Let's just get something easy and something lighter, just to have ourselves indulging into geometry today. First exam question. In the diagram, MP is the diameter of a circle. Here it's M and there is P, the diameter of a circle, centered at O. There it is. MP cuts the chord and R at T. There it is. T is there. Radius and O and chords PR, MN and MR are drawn. The angle R1 equals 69 degrees. The angle R1 equals 69 degrees. Determine, given reasons, the size of the angle R2. The size of the angle R2. This is it. This one here. You have 2 minutes. What is the size of the angle R2? Too obvious. Too obvious. All right, how far is it? R2.
I'm done with 8.1.1.
Okay, what answer did you get?
21.
Well done. Because the angle MRP, the angle MRP is actually exactly 90 degrees, an angle in semicircle. So the angle MRP is actually exactly equal to 90 degrees. Why is this the case? Angle in semicircle. Angle in semicircle. So that the angle R2 is actually exactly equal to. The angle R2 is exactly equal to 90 degrees minus 69 degrees. 90 degrees minus 69 degrees. And here is our calculator. And the minute we do 90 minus 69, 21 degrees exactly. So this gives us exactly 21 degrees. This gives us exactly 21 degrees. So this would be the result. Okay, so now we want to find the angle O1 next. The angle O1 is next. What is the size of the angle O1? And the angle O1 is this one here. What is the size of the angle O1? You have 2 minutes. You have 2 minutes. Exactly 2 minutes. How far is it?
I'm just about done.
Okay.
Okay, angle O1 equals to 138.
The angle O1 equals 138 degrees. The angle O1 equals 2 times 69 degrees. And 2 times 69 is 138 degrees. What is the reason for this? Angle at center.
It's 2 times.
Well done. Is 2 times equals 2 times angle at circumference. 2 times angle at circumference. 2 times angle at circumference. 2 times angular circumference. Okay, next. Okay, now we want to find the size of the angle M1. This one. The size of the angle M1. 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 How far? Right. How far?
I'm getting this,
Okay,
huh?
good. Right. How far? Too easy.
Hold on, I'm almost there.
Okay, that's fine. We're practicing, remember. We're not fault hunting here.
So they're not gonna be 21.
Exactly 21. Very well done. Because you already know that the angle R2 is 21 degrees.
Yeah, so
Check very carefully. You are able to see, therefore, that this is what we have here. And the minute you see something like this, the bow tie, these are angles in the same segment. This is the angles in the same segment, so that the angle M1, right, the angle M1 is actually exactly equal to the angle R2, and this is 21 degrees. Why? Because these are angles in the same segment. Angles in the same segment. Right, angles in the same segment. Angles in the same segment. Then now with these, then we're able to then say, yeah, we found the angle M1, so it's 21 degrees. And then now we're going to have the angle M2. The angle M2. If this one is 21 degrees and also this one is 21 degrees, The question then is, what is the size of the angle M2? This one. What is the size of the angle M2?
It's also going to be 21.
Okay, why would that be the case? What is the reason?
So since O is the center
Yes,
and N are cuts and joins to O, wouldn't
yes.
R and N equal to each other?
I'm expecting M2 to be 48 degrees.
48.
Yes, that's what I'm expecting. So any answer must be 48. If it's correct, of course. I'm expecting it to be 48 degrees, so any answer you get must be 48. M2 must be 48. Why would that be the case? Obviously, I mean, you need to calculate, but I've already done it. I've got 48, but I want to see if you can be able to get to 48. I know I'm giving you the answer to this one. So yeah, because obviously you gave me a 21, etc. But now I'm like, okay, let me just give you the answer so that you can compare with what you've got. So that you can compare with what you have got.
N O.
Right, I want you to explain how is it that you can be able to get to 48 degrees as well. Because the answer I've got is 48, but I want to see if you can get to the same answer with a reason or with reasons why that is the case. With the reason or with the reasons why that is the case. Right. With reasons on why that is the case. On why that is the case. Right. On why that is the case. Okay, remember that you have been given that if it is further given that NO is parallel to PR, NO is parallel to PR.
Hmm.
If NO is parallel to PR, what more can you extract from that? What more can you be able to deduce from that? If NO is parallel to PR, then you can get some alternate angles, yeah? Like you can be able to see that if this is 21 degrees, then also this one is also 21
21.
degrees.
Then O2 is gonna be, I said 42. And then
Yes.
P equals to O2, also
Yes, and P
alternating.
equals O2. They're alternate, yeah?
Then
Good.
right, then I got the angle T on the left hand side
Yes.
is 117.
Okay, good. So what would angle O2 be, for example?
Angle O2 is gonna be
I'm just
42.
teasing you. 42 degrees. Well done. Angle at center is twice angle at circumference, yeah? So if this is the case,
Okay, I got it now. Okay, I see.
you got it now. Okay, yeah, this is it. So we start by saying The angle O2 is actually exactly equal to 42 degrees. Why? Because this actually, you can then say this, in particular, I've already even got this because you
Alternating
got
angle. Oh,
138. This
180 minus.
180 minus, right? So you can get that one that way and then say these are angles on a straight line. Then your O2 is actually exactly 42 degrees already. And therefore, you're able to see that this one is also 42 degrees because these are alternate angles. So you're able to see that the angle P2, or the angle P, excuse, is 42 degrees. Now, if the angle P is 42 degrees, this means that you have alternate angles because you have NO is parallel to PR. NO is parallel to PR. And if NO is parallel to PR, so this is like 42 degrees. And then now you have the angle on M2. The angle M2, because you've already got the angle M2, will be the sum of the angles in this triangle. And therefore, it's 180 degrees minus, right, it's 180 degrees minus 69. Particularly, I can just say minus 90. Minus 90 degrees minus 42 degrees. Right, so now when I use the calculator, I got 48. You can just cross-check right now and see if that gives us the same result. So for example, you would then say 180 minus 90. It's therefore going to be plus 42 degrees. And this is exactly that. So you must add this one. Right, you must add this. So in other words, you will then say 180 degrees minus 90 degrees minus 42 degrees. 48 degrees exactly. So that the angle M2 is actually exactly equal to 48 degrees there. And this is the reasons we say the sum of angles in triangle. Here we then say the sum of angles in triangle. The sum of angles in triangle. Sum of angles in triangle. Any question on this so far, Lisedi?
No, sir.
No question. We move forward to the next one. We practice more and more. The next question looks like a butterfly of some sort, but it looks like an aircraft from Jupiter. Right in the diagram below, ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. A, B, and DC are produced to meet at E. We can see E. There it is. A, B, A, D, and BC are produced to meet at F. The point F is here. Right. A of B is double X. So we have the angle A of B, right? A of B is twice X, and the angle DAB is 3X. There it is, 3X. And the angle AED is X. So you have that the angle, right, AED is X. There it is. Here comes the question by the examiner. Determine, giving reasons, the value of X. Determine, giving reasons, the value of X. Please try the question. Determine, giving reasons, the value of X. Determine, giving reasons, the value of X. Okay, we have 3 minutes. Right. So we continue. We continue.
What I'm getting is 4x equals to 180 minus d2.
Okay, that's fine. That's okay. That's okay because we're practicing here. I'm trying to test you a little bit to make sure that you become a very good student. But now we start with the fact that the angle D1, you can do the angle D1 is equal to this plus this. So the angle D1 is 4x. That's what you can start by saying. The angle D1 is 4x. Why? Exterior angle of triangle. So in the end, then now you can also do with B1, in particular, you can get the angle D2. That angle D2 is 180 degrees minus 4x. Angles on a straight line. Angles on a straight line, because we have already got this one is 4x, and then we just say 180 degrees minus 4x. Okay, so that is sorted. That is sorted. Next, now right now you can get B1. B1 is this plus this, yeah? So the angle B1 is actually exactly 5x. Why is this the case? Exterior angle of triangle. Exterior angle of triangle. So that this angle is exactly 5x, and that is 4x there. And if this is the case, we actually are able to see very clearly at this point that we have exactly the following. The angle B1 is equal to the angle D2. The angle B1 equals the angle D2, which is exterior angle of slightly quad. Exterior angle of slightly quad. The angle B1 is 5x. The angle D2 we have already got 180 degrees minus 4x. You transpose the minus 4x. This yields the following. It yields 9x equals 180 degrees. Division by 9, both left and right, gives 180 degrees by 9, and this is 20 degrees, like so. And therefore, we are delighted to then say our x is 20 degrees. And any question on this, because we have to find the value of x. Our x is actually exactly equal to 20 degrees. Any question on this one so far?
So can you please re-explain how you got to B1?
Okay, right. How we got, for instance, B1, because now the angle B1, we can see clearly, if you look at this particular diagram here, that we have the angle B1, it's sitting here, and we go back to grade 10. And if you look at this particular diagram here, the angle B1 is equal to the sum of is an exterior angle, which is equal to the sum of the interior opposite angles in this triangle. So it means that
Yes,
B1 is 3x plus 2 is 5. You agree?
yes, sir.
Okay, good. So now we got that, and also obviously after having obtained that the angle B1 is also equal to D2. B1 is D2 exterior angle of a slightly quad. Yet the D2 is 180 degrees minus 4x. So you can just say the 5x is 180 minus 4x, and we solve for x there. And we've got the answer. We have got the answer. All right, and it was a very, very interesting question here. And we move on to the next question. Right, provided there's something not understand, about this particular question here. Remember, these are past exam questions. We are trying to prepare you for the exam. We are making sure that we go through hard questions and questions that can require you to reason a little bit, to analyze diagrams, and you must be able to interpret the diagrams correctly. And move on to the next question. If you are actually happy with this one, that is, if everything is very much understood here. Right, no question. So in the absence of a question, we move forward to the next one. We're going to send you this recording. I must be able to send the recordings later on today. I must be able to send the recordings later on today. Later on today. Let's move on to the next one. Here comes a nice geometry question. In the diagram, TSR is the diameter of the largest circle. So we have TSR is the diameter of the largest circle. Chord TQ of the largest circle cut the smaller circle at M. There it is. PQ is the common tangent to the two circles at Q. There it is. SQ is drawn. There it is. RP is perpendicular to PQ. Right, so you have that indeed RP is perpendicular to PQ. RP is perpendicular to PQ, making an angle of 90 degrees there. Now, MS is parallel to QR. MS is parallel to QR. Proof giving reasons that SQ is the diameter of the smaller circle. SQ is the diameter of the smaller circle. Okay, you have 3 minutes. You have 3 minutes. Right. How far? How far? Right. There it is. Right. How far, Sadie? Too easy. Too easily, Sadie.
Uh,
Yes, please.
uh, I said MS is parallel to, what is it? MS is parallel to QR.
Okay. MS is parallel to QR. Yes.
Yes, sir.
Given,
And
you
then
know?
given, yes, sir.
Yes.
And then angle S S2 is equal to Q2
Yes, that is true.
alternating.
Yes,
Wouldn't
the
that also
alternate angles. Yeah.
wouldn't that prove then the angle RP is also is per, RP is perpendicular to PQ?
Yes.
Wouldn't that prove that SQ is the diameter of a small circle,
SQ
therefore?
will be diameter of the smaller circle if only it subtends an angle of 90 degrees at the circumference. We'll have to prove that the angle M2 is 90 degrees. And that's all. And that is all. Right. All right.
Yes, sir.
So we continue. We continue. So now if you have these, and then you are able to see that at this point we have the angle M2, it must be 90 degrees. So you need a 90 degrees, but you already have a 90 degrees because this one is the diameter, this. And a diameter subtends an angle of 90 degrees at the circumference of the circle, making this angle here exactly equal to 90 degrees. And therefore, we're able to see clearly at this point that we have the following fact. What exactly do we have here? Is that the angle Q1 plus Q2 is 90 degrees. Clearly, this is the truth. The angle Q1 plus the angle Q2 is 90 degrees, and this is the truth. The angle Q1 plus Q2 equals 90 degrees, and this is the truth. And this is an angle in semicircle. It's an angle in semicircle, exactly like so. Because we know that an angle subtended by diameter is a right angle. And this is the diameter of the larger circle. Right. So we continue. We continue. Right. We continue. Right. Right. So we continue. Okay, we already said that Q1 plus Q2 is 90 degrees, is an angle in semicircle. And therefore, if this is the truth, if this is the truth, the angle M2 is therefore equal to, because this line is equal to, is parallel to this. And now in grade 10, we were taught that if this is parallel to this angle plus this angle is equal to 180 degrees. So that the angle M2 is actually exactly equal to 90 degrees. Co-interior. Co-interior angles from grade 10. These are co-interior angles from grade 10. Co-interior angles, why? Because MS is parallel to QR. Why would this be the case? This is given. This exactly is given. Like so. Let us continue with our geometrical analysis. Right, we have the M2 is 90 degrees, and therefore the line segment SQ right now, because we have already got that the angle M2 itself is actually exactly equal to 90 degrees. Therefore, SQ is a diameter. It's a diameter. Why would SQ be a diameter? It is the diameter because of the converse. The reason is converse. Converse angle in semicircle theorem. Angle in semicircle. Converse of the angle in semicircle theorem. And therefore, we are sure, therefore, that the angle, the chord SQ is the diameter of the smaller circle. We are sure of this. We are very sure of this.
So can you please help me 10.1.2?
Please come again.
10.1.2.
Please come again. You're saying what do you think about 10.1.2?
Yes,
Saying it's too easy.
no, sir, I need assistance.
Please come again. You need some help with 10.1.2.
Yes, sir.
Okay, because I thought maybe you're so energetic now. All right, that's fine. Remember, these are for us to practice and discuss. Okay, these are past exam papers, okay? And they've been brought for us to practice together. Because this 10.1.2 is too easy, but very, very straightforward. Let's tackle this question with so much renewed energy. And we begin as follows. Right, to start off with, we are looking at 10.1.2 and we're saying proof of giving reasons that RT is the ratio. Here is R and there is T in triangle. RTQ in triangle. RQP. We start off by realizing that the angle T is actually equal to the angle Q3. So the angle T is equal to the angle Q3. Why would this be the case? Because this is a tangent. This is a tangent. And this is the Tan-Chord Theorem. This is the Tan-Chord Theorem. Tan-Chord Theorem. So we have these is equal to these by the Tan-Chord Theorem. The angle Q1 plus the angle Q2
Equals to P.
Right, the angle Q1 plus the angle Q2, this one here, is actually equal to P and obviously equals 90 degrees. Right, but the fact that this angle here is equal to 90 degrees, why would that be the case? Once again, this is an angle in semicircle. It's an angle in semicircle. So first, Q1 plus Q2, because this one is a diameter, this diameter subtends an angle of 90 degrees at the circumference of the larger circle there. Next, the angle Q1 plus Q2 equals, right, the angle Q1 plus Q2
Equals P.
equals P. Right, so therefore the angle Q1 plus the angle Q2 would be equal to the angle Q1 plus the angle Q2 would be equal to the angle P, and the angle P is 90 degrees. Why is this the case? So yeah, this would be 90 degrees, and this is equal to the angle P there. And as a consequence, we have then shown the following facts. Right, this is it. We have the angle T equals Q. We have the angle Q1, Q2 equals P. And therefore, it remains that, in other words, we have that this angle here is equal to the angle Q. You have that the angle Q1, Q2, which is this angle here, is equal to the angle P. And therefore, we're left with the angle R2 and the angle R1. So it follows, therefore, that the angle R1 is equal to the angle R2. Why would this be true? Right, these are angles of triangle. Right, angles of triangle. So we have that these are angles of triangle exactly that way. And as a consequence, therefore, we are able to say the triangle RTQ is similar to the triangle, because the angle R is equal to the angle R, the angle T equals the angle Q, and the angle Q is equal to the angle P, and this is the case. Why would this be the case? Why would these two triangles be similar to each other? It's because of the angle reason. And therefore, with this, then we are in a position to then say, we can then see that RT over, so we do RT over RQ is equal to TQ, QP, RQ, RP. Can do this. So now we have written these proportions. If two triangles are equiangular, then the corresponding sides are in the same proportion and the triangles are similar. Okay, right, with these mentioned, would have exactly the following. Would have exactly the following. Right, you'd have exactly the following. Now, you'd have, according to this one, you need an RT, so you're going to take this one. And also you need an RQ, you're going to take this one. Good. Meaning, therefore, you're going to take RT over. You're going to take also RQ, and this must be RQ over RP, like so. Upon careful examination, we cross multiply, getting RT is RQ squared divided by RP.
Okay, thank you, sir.
Okay, good. And then we have been able to prove this. Any questions here or anything you would like to understand pertaining this question on similarity and proportionality?
No, sir, thank you, sir.
Okay, good. We move on to the next one. 10.2. This one is yours because it's too easy. If MS is 14 units, you have been told that MS is 14 units, and PQ is the square root of 640 units. Calculate giving reasons the length of the radius of the larger circle. Calculate giving reasons the length of the radius of the larger circle. We need the length of the radius. This is the largest circle. The radius is, for example, SQ from the center, or ST as well, or SR. Now we want to find the radius of the larger circle. Right, we have 3 minutes, too easy. You have 3 minutes. We want the radius of the larger circle. Radius of the larger circle. Right. Right, how far? Right, we continue. We continue. Right, how far?
I got 28.
You got 28. That sounds very interesting. It sounds so interesting, and we take a look at that one and see how well we can analyze that particular question. And let's see what we can do. Okay, right. You'd remember from the previous question that we have the following. We have RT over this. Right, from the previous question, we have RT is equal to RQ squared over RP. This is it. Right, so RT. Right, RT is equal to RQ squared. Right, RQ squared divided by what? Divided by RP. Like so. Let us analyze these together. So this one has been proved. It has been proved in the previous question, 10.1.2 above. 10.1.2 above. Okay, we're trying to expand your reasoning. We're trying to train your mind here. So now we go back to grade 10, the midpoint theorem. And the midpoint theorem is clear that the length of the chord QR is 2 times 14. 2 times 14 is exactly 28 units. Like so. Because now, if this is the midpoint, this is the center. So this is a radius and that's a radius. And if this is parallel to this, also this one is equal to this one. By the midpoint theorem, the length of this side, therefore, is actually the same as this one by a factor of 2. So this length is 2 times that one. So that now in the end, then we have QR is 2 times 14, which is 28. And this reason is great tan, the midpoint theorem. Like so. Right. It's called the midpoint theorem. Midpoint theorem. And this is it. At this point, if we know that this one is actually exactly 28, so we can just be in a position to get our RP there. Right, because we've already got our QR or RQ. We just need to get RP there, and then we're going to use our Pythagoras theorem there. All right, so in other words, we're going to say in triangle, RQP. Right, in triangle, RQP. So that now you have RP squared, which is 28 squared minus the square root of 640 squared. And this is Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. So that you have RP squared is 28 minus 640. This is 144. You take the square root and we have RP squared square root. The square root of 144 is clearly the same as what? It's the same as RP equals 12 units. RP equals 12 units. So now we have our RP, we have our RQ squared there, so we get everything we want. So now we need RT, but we can clearly see that if this is R and this is T, this is a diameter. This one is a diameter because it passes through the center of the larger circle. So we shall get RT, and then we are able to then say RT. RT is actually exactly RQ squared. You divide by RP. Like so. What is RQ squared? 28. Divide by RP, 12. But this 28 is squared. It is squared. Right. So now we're going to use our calculator. Let's launch our calculator and perform some basic arithmetic here. So we're going to have, for example, exactly the following. 28 squared. We divide by 12. The answer. 196 divided by 3. 196 divided by 3. And therefore, this is 196 divided by 3. Like so. So that the radius. The radius, therefore, if this one is the diameter, is half. This is half RT. RT is 196 divided by 3, which is 98 divided by 3 units. 98 divided by 3 units, and this is the radius. Because the question said, calculate giving reasons the length of the radius of the larger circle, and this is it. The length of the radius is 98 divided by 3 units of distance. Any question on this one so far? Anything you'd like to understand? In grade 10, you were taught about the midpoint theorem. Midpoint theorem. Right, the midpoint theorem is clear. This A, B, C, P, Q. right? If this is the midpoint, if Q is the midpoint and P is the midpoint, we say a line segment joining the midpoints of two sides of a triangle, right? This is called the midpoint theorem. Let us speak about the midpoint theorem. Midpoint. Midpoint theorem. Midpoint theorem is done in Greek 10. Right. And we say that a line segment joining the midpoint of two sides of a triangle. Line segment joining the midpoint of two sides of a triangle is such that, okay, I want to bring your attention to the theorem here on the sketch. So you have P, Q, and you have A, B, C. So now then you need to have the following. So a line segment joining the midpoint of two sides of a triangle, right, is parallel to the third side, parallel to the third side, and equals half the third side. Grade 10. You need to remember grade 10 work. And equals half the third side. Right. So it is part of the third side and also equals to half the third side there. In other words, the length of the PQ is half of BC. It's half of BC. Yet the PQ is parallel to BC. So now the midpoint theorem is clear. As L is grade 10, a line segment joining the midpoint of two sides of a triangle is parallel to the third side and equals half the third side. Equals half the third side. Any question about the midpoint theorem?
No, sir.
Okay, good. It was used here. And then now I want us to move on and practice more. Here is another nicer question. Right. In the diagram, M is the center of the circle. Here it's M, and it's the center of the circle. A, B, and C are points on the circle, such that AC equals BC. Right, with AC here is equal to BC, like so. And PA is the tangent to the circlet A. Right, so we have the point A here, and you can see PA is the tangent to the circlet A. PQ is drawn parallel to CA to meet BA produced at Q, and you're able to see this. BC produced meets PQ at R. R is clear, and AR is drawn. Right, you have exactly AR that has been drawn. Let the angle Q be equal to X. Let the angle Q be equal to X. Determine giving reasons. Four other angles, each equal to X. We start. The marathon is here. This is it. This is it. Now, I want you to give four other angles, each equal to X. Let's start. You have 4 minutes. We're training the mind. We are training the mind. We are training the mind. Determine four other angles, each equal to X. Right. So we continue. We continue. Right. How far, Lisedi?
I'm on my second X value or
Okay,
X.
what
Fine.
is the first one? What is the first you have got?
BAR equals to Q equals to X.
You're saying BAR. Did you say BAR?
Yes.
Okay, let's check. BAR.
Oh,
Right.
P.
Did you say P? Okay.
Yeah.
PAR. Okay, that's fine. Was
No,
it
no, no, no.
this one?
Changing the R to P, not.
Oh, okay. So, okay, did you say BAP?
Yes.
Okay, so now you're then saying, right, BAP is equal to what?
Is
Is
equal
equal
to
to
Q.
is equal to Q. Okay, BAP is equal to Q. Why? What is the reason? Okay, I'm hearing you. Is equal to Q is equal to X. Obviously, I can't say no until I get the reason from you. What do you think is the reason for this?
Exterior angle,
Exterior angle.
yes,
Okay, good. Now, obviously, you are on point on this one. You certainly are on point, but there's a small error. Well, this is too wide to be equal to this. The exterior angle would have to be this plus this,
Okay.
right? From grade 10. If you have this C, A, B, C1 is A plus B. Exterior, so you say C1 is A plus B, and this is exterior angle of triangle. Exterior angle of triangle, right? So what do you think? So we need new ideas here. We need to think afresh. You need to think anew. You need to think anew. Right, we need to think anew. Right, so what do you think right now? I hope I'm not roasting your mind. I hope I'm not frying your mind like somebody frying eggs in a pan. I hope I'm not doing that. I'm trying to get you to reason. I'm trying to get you to think. These are past metric questions. past grade 12 papers. We are going into detail. We're going even deeper every day, deeper and deeper. Both papers 1 and 2, we are drilling everything until your mind has learned, until you have mastered the curriculum. And that is the objective. So we need more clues. We need more answers. We need more answers. So think about it. Think about it. Think about it. Right. Right. Right, 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 right. So we continue. We continue. How far? Lissetti.
No progress, eh?
Right, too easy. We go back to grade 10. Right, in grade 10 we're taught that if you have this shape here, this line parallel to this angle equals this angle. And these were said to be corresponding angles. Therefore, if we have this one here that goes down like this and this goes down like this angle is actually equal to this angle, for these are parallel to each other. So that the angle A1, right, the angle A1 is also equal to x. And these from grade 10 were said to be corresponding angles. Corresponding angles. Why is this the case? Because PQ is parallel to CA, like so. We have found one angle. Next, we need to find more angles. This is not enough. Can you find more angles, please?
Mhm. A1 equals to B.
A1 equals B. Well done. So the angle B, right, the angle B is also equal to x. Why will the angle B be equal to x? The angle
Angles
B equals to x,
opposite
yeah?
equal sides.
Angles opposite equal sides. Angles opposite equal sides. Well done. Next, we need more angles, please. We need more angles. So this one is x as well. But there are more. There are more. There are more. How far, Lissetti? How far, Lissetti? How far is it? There are more angles equal to x, but what are they?
Can you say B and hold on and P?
Can you say B and P? Why
Yes,
would that
sir.
be the case? Yeah, that's interesting. But why? What would the reason be?
Because I see in the next question we're gonna have to prove that it's a cyclic quad.
Yes, you'll have to prove that it's a cyclic quad. That is
Cyclic
correct.
quad.
Yeah. Yes.
So if we can prove that the bow tie method works, won't that work, sir?
Yes, if you can prove that the bow tie method works. If you can prove that the bow tie method works, yeah, that's fine. We can establish that. But now we need other angles equal to x. Let's find more, please. Let us find more. We need more and more. Okay, by the Tan-Chord theorem, because we're told that we have PA is the tangent. So if PA is the tangent like this, then we know very well that this here is the Tan-Chord theorem, so that this angle here is equal to this angle there. The angle A2. Is equal to x. Why? Tan-Chord theorem. Tan-Chord theorem. Next, we found that A2 is also x. Can you give other angles that are equal to x, please?
Pardon?
We need one more. Because we found 3. But the examiner in the metric paper said 4. This is the past metric paper. They said 4. What is the fourth one? Because we have
One is P.
1, 2, 3. The 1 is missing.
The fourth one is P. A
The
equals
fourth
to
one is
P.
P. Well done, because we go back to grade 10. These angles are alternate. So which means that the angle P is x. Why would this be the case? These are
Alternate.
alternate angles. Why alternate? Because
That
PQ is parallel to what? Is parallel to CA. Good, because PQ is parallel to what? Is parallel to CA. PQ is parallel to CA. Any question?
no, sir.
All right. I think that it was awesome having this discussion. This one is your home activity.
So,
Right. Yes,
with
please.
regards to yesterday's thingy
The recording.
session, yeah, I did not get it.
Yeah, I'm gonna send it today with this one.
Okay, thank
Yeah,
you,
I'm
sir.
gonna send both of the recordings. The recording of yesterday and today's recording in the next couple of minutes. After this lesson, I'm just gonna send you the recordings so that you can be in a position to watch them. Okay, so 9.2.2 is your home activity, and yeah, obviously you don't need to copy down because you're gonna watch the recording and you can just fast forward. You can just fast forward the recording to the end so that you can see the home activity. Okay, there are many questions, but yeah, I don't want to break your I don't want to break you. I want to build you up. So just try this too. And then we shall continue also tomorrow. Okay.
Thank you, sir.
Right. Thanks a lot. It was awesome having this discussion. Until tomorrow evening. If tomorrow you are busy or if you are busy on a given day, you are let me so that we can actually obviously schedule you on a given day. But we want to do the 8 lessons like consecutively, successively, so that we can do the most we can. Okay.
Yes, sir.
Right. Otherwise, it was awesome having this discussion with you, Lesedi. Until tomorrow, and we shall see the recording just tonight. Take care. Goodbye, and
Thank
God
you, sir.
bless.
Bye.
All the best, Lesedi. Goodbye.